Welcome to This Explainer. Today, we're diving into something absolutely essential. We are translating traditional network engineering into Linux concepts. And, well, you might be wondering, why? Because the days of managing infrastructure purely through proprietary command line interfaces are quickly fading. Today, we treat infrastructure as code, and the bedrock foundation of all that automation is, you guessed it, Linux. Just look at this quote for a second. It perfectly hits the nail on the head. Understanding Linux isn't just a nice-to-have anymore. It's literally becoming a mandatory skill for our careers. Modern network operating systems are increasingly Linux-based, and they're exposing their internals directly to us. Plus, all the automation workflows we rely on daily, think Python, Ansible, Git, containers, they are all inherently built to run from a Linux jump host. So here is our roadmap for today's crash course. First, we'll cover why Linux matters now. Then, distributions and the shell. Third, navigating the Linux file system. Fourth, files, permissions, and scripts. Fifth, troubleshooting Linux services. And finally, number 6, Linux networking and VLANs. All right, Section 1, Why Linux Matters Now. We're moving from the legacy CLI to modern automation. Now, what's really interesting here is that Linux isn't just one big monolithic operating system. It actually comes in different families or distributions, and their package managers dictate the exact commands you're going to use to install your tools. So on the Red Hat side of the family, which includes CentOS and Fedora, you're dealing with RPM packages and using yum or DNF commands. But over on the Debian branch, which includes Ubuntu, you use deb packages and rely heavily on apt commands. Knowing which family your jump host belongs to is literally the difference between pulling your hair out over an error message and smoothly installing Ansible on the first try. Moving right along to Section 2, Distributions and the Shell. This is the environment where we actually get our work done. Okay, before you fire off any potentially destructive automation scripts, you need to read the shell prompt. It's brilliantly simple but tells you exactly who and where you are. It shows your logged-in user, the system's hostname, and your current working directory. But the absolute most crucial detail is at the very end. See that $sign? That means you're a normal user. But if you see a hash symbol, watch out, you have root or elevated privileges. It's exactly like moving from user X to privileged X mode on a Cisco router. Tread very carefully when you see that hash. Let's jump into Section 3, Navigating the Linux file system, finding your way around the machine. You know, a surprising number of automation failures happen simply because an engineer runs a script from the wrong directory. So let's clear this up. Linux uses a single root file system, meaning everything falls under one giant umbrella represented by a /, that's the root. A tilde is just a handy shortcut for your personal home directory. A single dot represents exactly where you are sitting right now, and 2 dots mean the parent directory, one level up. Understanding absolute paths, which always start at that root /, versus relative paths, which start from wherever you currently are, will save you hours of troubleshooting when your Python script suddenly can't find its config files. And to get around, here are 3 super friendly commands you're going to use constantly. pwd prints your working directory. It basically answers the question, where on earth am I right now? cd changes your directory, letting you move around the file system. And ls lists out the contents of whatever directory you happen to be in. Which brings us nicely to Section 4, Files, Permissions, and Scripts. Essentially, your automation toolkit. All right. Here is your core toolkit for managing your script files on the server. Touch creates a quick, empty file, mkdir makes a brand new directory, cp copies files, mv moves them, or fun fact, effectively renames them if you keep them in the same spot, and rm removes them. It's incredibly straightforward, but very powerful. Now I've got to give you a massive gotcha warning right here. The rm command deletes individual files, sure. But if you want to delete an entire directory and everything nested inside it, you use rm-r for recursive. Listen to me on this. Deleting a directory recursively in Linux is permanent. It does not behave like Windows or Mac OS. There is no helpful recycle bin to fish your deleted files out of later. Always double-check your paths before hitting enter. Okay, so understanding these cute little RWX characters is absolutely crucial to knowing if your script actually has the rights to run. Linux secures everything through permissions. R is for read, W is for write, and X is for execute. Let's say you write an amazing automation script, but it doesn't have that X execute permission. Linux simply will not let it run. No exceptions. You use the chmod command to change these permissions. For example, typing chmod plus x makes a script executable, and chown is what you use to change who actually owns the file. So imagine this scenario. You've got your script, you made it executable, you proudly type its name into the terminal, and Linux just spits back command not found. Why? Well, Linux searches for programs using a specific environment variable called $path. You can actually view it by typing echo $path. Because your current directory is intentionally not in that default search path, you have to explicitly tell Linux to look right here in this exact folder. You do that by typing // before your script name, like /script.sh. All right, Section 5, Troubleshooting Linux Services, Keeping the Network Running. Let's pivot slightly. In Linux, background processes are called daemons. Think of your SSH server, a DHCP service, maybe an API server, or an automation worker. When an API call or SSH access suddenly fails, checking the daemon status with the systemctl command is your very first troubleshooting step. You can check the status, you can start or stop it, or issue a restart to bounce the service after you've made a configuration change. And finally, we reach Section 6, Linux Networking and VLANs, the network engineer's true comfort zone. Let's start translating traditional routing concepts right into Linux syntax. Now, the older ifconfig commands have been deprecated, so we use the modern iproute2 suite. These 3 simple IP commands are the bedrock for verifying how your Linux machine interacts with the rest of the network. IP-link shows you if your layer 2 interfaces are up or down. IP-address shows you the layer 3 IP addresses assigned to them. And IP-route prints out the routing table, showing you exactly how that Linux box is going to forward traffic. Okay, let's look at this actual syntax in action. It's incredibly logical once you see it. IP-link set eth1 up brings the interface online. That's basically your no shutdown command. Next, IP-address add assigns a specific IP and subnet mask to that interface, which Linux refers to as a dev or device. And finally, IP-route add creates a static route to a destination network via a specific next hop gateway. But here is the absolute biggest trap in Linux networking, so pay attention. Using those IP commands we just talked about, that only changes the active state of the kernel. It is exactly like modifying the running config on a Cisco router, meaning if you reboot that server, all those IPs and routes just vanish. To make them permanent, you have to write them into persistent network configuration files. Think of those files as your startup config. Depending on your distro, this is usually handled by Netplan on Ubuntu or Network Manager on Red Hat. Did you know a Linux box can act just like a software-defined switch? It's true. You can easily spin up logical VLAN subinterfaces right on top of physical ports. For instance, if you have a physical interface eth2, you can use the iplink add command to define a logical link named eth2.150, specifically tagged for VLAN 150. But remember the golden practical networking rule here. For this to actually work, the upstream switch port it's plugged into must be configured as an 802.1q trunk and explicitly allow VLAN 150. So let's wrap this up. We've seen how understanding distributions, mastering the bash shell, securely navigating the file system, and manipulating the networking stack directly from the command line aren't just sysadmin tasks anymore. They are absolutely core network engineering skills. So I'll leave you with this. If the modern network is now literally built on Linux, are you ready to treat your automation jump host as the ultimate programmable switch? Thanks for joining me on this explainer. Dive into those terminal prompts and keep learning.